So in this video, I wanted to do some examples of finding the derivative of functions using the definition of derivative. Now, the definition of derivative, remember, is we take the we find the slope of the secant line. So that'd be y1 minus y2 over x1 minus x2. So we take the slope of the secant line. So if you got a curve like this, you got a point here and a point here. We're going to call this x, and that x plus h, which would make this f of x, and that would make this f of x plus h. So you can see that that equation I just wrote there is the slope of that line, or the secant line. So we're going to start with that, and then what we do is we put a limit in front of that and let h approach 0, because that'll cause this secant line to get closer and closer to the tangent line, which is what I'm actually interested in. Okay, so that's the definition of derivative, because the derivative is just the slope of the tangent line, or the instantaneous slope at that point. Okay, so if we're trying to find the derivative of this thing right here, this f of x, then we're going to plug this into my formula here. So I'm going to take the limit as h approaches 0, and f of x plus h would be replaced with x plus h squared plus 2 times x plus h. Notice I'm just, everywhere I see an x in the function, I'm replacing it with an x plus h. So that right there, if I grab a highlighter real quick, so I've just done that. All of this is that yellow stuff up there. And I'm about to do this. So then I'm going to subtract, and I'm going to put parentheses around it so I don't mess this up. And this is just going to be f of x, which is just x squared plus 2x. And of course, in the bottom, well, x plus h minus x is just h, so I can just write that. Okay, just to make clear what happened there. And so that blue, of course, just became this right here. Okay. Oops, forgot to get my pen back. Okay, so now once we've done that, we've got to do a little bit of algebra, because if I just let h approach 0 right now, the bottom is going to be headed towards 0, and we never are very happy about the bottom heading towards 0, because that just leaves me undefined, right? So I'm going to take the limit as h approaches 0, because I haven't taken that yet, so I still have to write it. And of course, x plus h squared would be x squared plus 2xh plus h squared. And 2 times x plus h would be 2x plus 2h. And if I distribute that negative sign, I get a negative x squared and a negative 2x. Of course, all that stuff is over h. So again, I'm going to take a limit as h approaches 0, and the x squared minus x squared is 0, and the 2x minus 2x is 0. So I'm left with 2xh plus h squared plus 2h all over h. And I notice that h is a factor of top and bottom, so I'm going to cancel those out. So then I'm left with 2x plus h plus 2. Now I think I'm ready to do the intuitive approach of evaluating the limit again, and I'm going to say let's let h approach 0. If h approaches 0, then this whole expression gets closer and closer to 2x plus 2. So what does that mean? That means that the derivative of this function is 2x plus 2, which means I can use this formula to find the instantaneous slope of this graph at any point. Or if f of x has some context, like maybe it means something in the real world, then this formula will find the rate of change of that thing at any point in terms of, or at any x value. So that is finding the derivative. Let me do another example. Let's say we wanted to find the derivative of f of x equals, say, 1 over x plus 2. Oops. 1 over x plus 5, let's say. So once again, I'm going to take the limit as h approaches 0 of 1 over x plus h plus 5, just replacing x with x plus h, minus 1 over x plus 5, and all that's going to be over x plus h minus x. So let's simplify that real quick. The limit as h approaches 0 of 1 over x plus h plus 5 minus 1 over x plus 5, and the bottom becomes just h. So this is a complex fraction, so the way I can simplify complex fractions by multiply top and bottom by the same common denominator, and in this case the common denominator is going to be x plus h plus 5 times x plus 5. So I'll multiply the bottom by the same thing. So then we have the limit as h approaches 0 of, now when I multiply this times this, I get just 1 times x plus 5, which would be x plus 5. And when I multiply this by that, the x plus 5 cancel out, and I get just an x plus h plus 5, but of course that's being subtracted because of that. And on the bottom, I have h times x plus h plus 5 times x plus 5. Now some funky stuff happens up here. X minus x is 0, 5 minus 5 is 0, and I'm left with just a negative h on top, and of course h on the bottom, and an x plus h plus 5 times x plus 5. The h's cancel out, and I'm left with the limit as h approaches 0 of negative 1 over x plus h plus 5 times x plus 5. Now I think I'm ready to let h approach 0 again, and when h approaches 0, this piece right here becomes just x plus 5. So as h gets closer to 0, this overall expression gets closer and closer to negative 1 over x plus 5 squared. So if f of x equals 1 over x plus 5, then the derivative of that would be equal to negative 1 over x plus 5 squared. Okay, I think I'll do one more example. Let's say that I have f of x is equal to the square root of, let's do it on the outside. How about the square root of x plus 2? So once again, we take our limit as h approaches 0, and we're going to do the square root of x plus h plus 2 minus the square root of x plus 2. Of course, that's minus the whole thing, right? On the bottom, I have x plus h minus x. So let's clean some stuff up here. Limit as h approaches 0. 2 minus 2 would be 0, so we're left with on top just x plus h minus, square root of x plus h minus the square root of x. And on the bottom, I have just an h. And of course, if I try to do an intuitive approach here, as h approaches 0, the bottom approaches 0. And that's not a very fun fraction to deal with. So I notice there's radicals in the top. So I'm going to use that technique of rationalizing the numerator. So I'm going to do the square root of x plus h minus the square root of x. The bottom, the same thing, the square root of x plus h minus the square root of x. And when I do that, this times this, okay, the limit as h approaches 0. This times that is just x plus h. And this times this and this times this. Oh, whoops, that's supposed to be plus. Those should be opposite signs. So this times this and that times that cancel each other out. So then I'm left with a negative square root of x times square root of x. That, of course, is just negative x. And those x's are going to cancel each other out. So I'm left with the limit as h approaches 0 of h on top, h on the bottom, which are going to cancel with each other, And I still have this stuff inside the parenthesis. So that gives me the limit as h approaches 0 of 1 over square root of x plus h plus the square root of x. Then when I let h approach 0, this thing gets closer and closer to 1 over 2 times the square root of x. Notice that as I'm doing this, I'm writing the limit over and over again because I have to have the limit there until I've taken the limit. So that's an important thing to note. But then once I let h approach 0 and calculate it, then notice I don't write the limit anymore here because that's just my answer. So again, what this means is that if f of x is equal to the square root of x plus 2, well then f prime of x is equal to 1 over 2 times the square root of x. All right, thank you very much.